This video is to introduce you to the AS section of statistics for the maths AS level. It shouldn't be much of more than you've learned, or if anything, no more than you've learned at GCSE. So but it's a good recap, and it's worth watching the video just to make sure you're okay with it. So this particular PowerPoint has been taken from the Dr. Frost website, and you can access that for free and do lots of practice questions there. People from Hillary's class, you can actually, I did send you a link so that you could sign up specifically for this class, for our class, but you can just sign up yourself and practice if you want to. So what we're doing, just out of interest, that's Marie Curie, who was a leading pioneer in statistics, and we've gone through all the experimental probability. Don't worry about the fact it's saying chapters. That's referring to a textbook that we're not using. But the one we're looking at now is probability. So Venn diagrams, mutually exclusive, independent events, and tree diagrams. These questions here then are giving you an idea of what your objectives are for the lesson, because you should be able to answer these questions by the end of the lesson, if not already. So it's worth pausing. You can even give them a go, and then you'll find out at the end of this video what the answers are. So an experiment is a repeatable process that gives rise to a number of outcomes. So in this case, we're thinking about rolling a die. One of the events that we're focusing on, so an event is a set of one or more outcomes. One of the events we could be focusing on is rolling an even number. So within this oval here, we've got all the outcomes that are even numbers. And the other oval contains all the prime numbers. So the event is rolling a prime number when you roll a dice. And the only event then that, the only outcome that isn't part of either of those two events is the number 1, because that's not prime and it's not even. And so we fill it in, and because this is a Venn diagram, we have to put a rectangle around it, and you'll see that later on. So we can use a Venn diagram where the numbers are the individual outcomes and the sample space is a rectangle. So a sample space is the all the possible outcomes. So it's as it says here, set of all possible outcomes. That bit's important, the set of. We can also use a sample space diagram to record outcomes depending on what we're looking at. So we'll have a look at that now. So read this example, and then if you can draw a sample space diagram and use it to calculate these two probabilities, that would be great. So I'm assuming you've just paused the video, and the answers you should be getting are here. So for the sample space diagram, this is what it looks like. So spinner 2 could have the numbers from 1 to 4, spinner 1 can have the numbers from 1 to 4, and each of those outcomes is equally likely, which means all of the entries in the sample space diagram have a chance of 1/16 of happening. So if there are 4 outcomes which are 5, then the chance of getting 5 is 4 out of 16. And the chance of getting a number that's more than 5, there are 6 of those outcomes out of 16. So that's 3/8. So if you can again pause and read the example, and we'll go through it in a moment. So the probability that the student chosen at random completes the puzzle in under 9 minutes. I'm not sure about the wording, but that's the idea. We've got 19 students that completed the puzzle in under 9 minutes. So the chance of that student completing a puzzle in under 9 minutes is 19 out of 40, because there are 40 students in total. The next one is a little bit more tricky, I suppose, because we haven't got an exact cutoff for where 10.5 is, but 10.5 is from 10.5 to 11, that's a quarter of the distance from 9 to 11, and a quarter of 12 is 3. So if we assume, and assuming in probabilities is a dangerous thing, but we're assuming that the people were equally spread out in this time range. So there are 3 people from 10.5 to 11, and then another 9 people that are above that. So in total, we've got 3 plus 5 plus 4 out of 40. This number's wrong. It should say 40. And that cancels down to 3 out of 10. Now we're looking at Venn diagrams. So Venn diagrams allow us to look at combined events. So here's a Venn diagram where you've got events A and B, and the shaded part is the event A and B, so everything in there would be A and B happening, known as the intersection. The event A or B means that A could happen, B could happen, they could both happen. So it's called inclusive OR. Some of you might have met that in computing. And it's known as the union. We've got here the event of A not happening because everything outside of A is shaded. And then finally, for these Venn diagrams, we could look at the event of A happening but B not happening. So in this section here, A is shaded but B is not shaded. So that's A happening and B not happening. You could similarly have B happening and A not happening with this section here just shaded. So we can either put frequencies or probabilities into the Venn diagram, doesn't matter which, so long as you use them correctly. So you've got some information here, pause the video and give it a go. So hopefully you've drawn a Venn diagram that looks like this. And I'd advise a lot with questions like this, draw the Venn diagram, fill in the numbers and then answer the question because it usually falls out quite nicely for you. So we were given probability of A being 0.6 and there's no other information we can use to separate it. So it's just 0.6 here, which means that if the A or B is 0.85, that must mean that this part, the probability of B not A, is 0.25. And then if we know that all of this altogether is 0.85, then 1 minus 0.85 is 0.15, which is the probability of neither A nor B, and that's written down here. So what we've got here is another question, which again I would advise strongly that you pause and try it yourself first. So to fill in the Venn diagram, the very first thing you say, and it's a tip that's here, the very first thing to do is to fill in the intersection. So for a three-way Venn diagram, that's the same idea. And the information given is that there are 7 people that own dogs, cats and tropical fish. So the 7 goes in the intersection. We're told that we've got 25 owned dogs, but at the moment we can't do anything with that. We are told that 15 own dogs and cats. That's 15 people that own dogs and cats, but 7 of those people also own tropical fish. So the people that own dogs and cats but don't own tropical fish must be 15 minus 7, which is 8. Similarly, if we find the part that, so we've got here 10 own cats and tropical fish. So cats and fish means that in total that has to add up to 10, so this must be 3. And for this one here, we've got dogs and fish. So 11 own dogs and tropical fish. So that must be 4 in that area. In total then 25 own dog, I don't know why I keep saying 25. 25 own dogs, which means in total that circle has to add up to 25. For the cats, it needs to add up to 53. Couldn't find it there. And here, that should add up to the fish total 40. So that's 26. So you can just check they all add up right. And then if you add together all of those numbers, then you should find that in total, if it doesn't equal 100, I'm not quite sure why people would be going to the vets if they're clients, but they don't own, I suppose they own other pets. Oh, took me a while to work that one out. And so in total, that number there, 11, is what you'd have to add on to the rest of them to get 100. So now, from the Venn diagram, we can get all our answers. The probability that someone owns only dogs, there are 6 of them out of 100. Does not own tropical fish, so people that don't own tropical fish is, well, we could have done that anyway, because 40 own tropical fish, that means 60 don't. Got a sneeze coming. There we go. Sorry, I would pause it, but I don't know how, and then it saves the video, and I just can't cope with that. So then, probability that someone does not own dogs, cats, or tropical fish we've got on the outside, so that's 11 out of 100. You can have a think about also, if I told you that someone chosen at random definitely owns a cat, what's the chance that they also own a dog? So this isn't on the PowerPoint, it's just popped into my head as some kind of random thing. So if we say that someone, it's given that they own a cat, that means that we are not in any way interested in any of the outside circles now. We're just interested in this cat circle. And we want the probability that, given that they own a cat, what's the chance they own a dog? So the people that own a dog and a cat, that's 15. So the chance of owning a dog, given that they own a cat, is 15 out of cats 53. Okay, and we'll see that again on the next slide with a different example. So this is a past paper question. Read through the question, pause the video, try it. So part A, I'm going to reveal now. So it shows you it's breaking down the marks that you would get, and that tip there, you'll lose a mark if you don't put a box around it. I'm not going to try and start singing Beyonce, but yes, you need to put a box around that. It is possible to have either the actual frequencies or the probabilities in those sections. Part B then, we've got 7 out of 100 or 0.07. That's, none of them takes the exercise, so that's out here. Part C, swims but does not run. So if someone swims, they're in this circle, but they're not allowed to be one of these two people. So there's only 8 of those. So that's 8 out of 100. And then for part D, takes at least 2 of these types of exercise. So at least 2 means 2 or 3. So there are 10 people that run and cycle. I'm ignoring the 25 that do all 3. There are 5 people that cycle and swim only, and there are 15 that run and swim, and then you've got these 25 that do all 3. So you add those numbers up and you get 55 out of 100, so that's 11/20ths or 0.55. The last question didn't have the part of the mark scheme, so I've just typed up the answers for this one. So Jason's one of the above group. Given that Jason runs, so Jason is definitely a runner and he's part of the group, so he is somewhere in this circle for sure. So you can forget about anything else, it's just that circle you're interested in. Find the probability that he swims but does not cycle. So in order to swim, there are 15 people that swim but don't cycle. So that means that there are 15 people out of the runners, which is 65. So 15 out of 65 is the chance that Jason swims but does not cycle. And that's the same as 3/13. This is called conditional probability, which you may have met, but it's not formally known as conditional probability on the AS specification. You just are supposed to be able to use, I suppose, apply common sense to answer it. So now we're looking at mutually exclusive events, and they are events that cannot happen at the same time. So if we look at a Venn diagram, if events can't happen at the same time, then there's not going to be any overlap because there's no chance of them happening at the same time, which means that the probability of them happening at the same time is 0. And the probability of either one or the other happening, you can just literally add those two together, the probability of A and the probability of B. These are really important facts which will almost certainly come up if a probability question is in the exam, along with independence. That's also one that comes up, and it is incredible how many people don't spend the time to really make sure they have that information in their heads. So please, can you make a note of it and make sure you are applying it. So you're looking for those words mutually exclusive. Okay. Now, information about independent events. So if you're independent, then you aren't influenced by other people, supposedly. So independent events are ones that do not affect, so if one happens, it doesn't affect the probability of the other one happening. And if they're independent, then you can multiply the two probabilities to get the probability of A and B. This is not a rule that you can use unless events are independent. Now, if you could just go back in the video a few seconds and keep playing that until it's gone into your head, that would be brilliant. Okay, read the example and try the question. So the probability of picking a multiple of 2 is a half. The probability of picking a 4 is a quarter. So conceptually, why would it be that these two events are not independent? Does the probability of one happening, if one of them's happened, does that influence the chance of the other one having happened or happening? So if the number is a multiple of 4, then it must also be a multiple of 2. But if it wasn't a multiple of 4, then it may or may not be a multiple of 2. So the event of for that particular one happening is influencing whether or not the other one happens, or the level of probability, the level of chance. So the events are definitely linked together, and whether one happens influences the other. So they are not independent. And to show they're not independent, we have to use that rule there. So we have to show that when we multiply the probabilities, we don't get the actual value that you would have for the probability of picking a multiple of 2, and that's also a multiple of 4. So the probability of picking multiple of 2 multiplied by multiple of 4 is 1/8. But if you get a multiple of 2 and a multiple of 4, that's 1/4, because that's just the number 4, isn't it? 1/8 does not equal a quarter, therefore they are not independent. And this is very important. It's a very common exam question, more common than the mutually exclusive, but they could put both in if we're really lucky. So they expect you to show that, or to show they are equal, or show they aren't equal. So if you could try these questions and pause the video. I'm not going to explain in detail these answers, but I'm going to reveal them for you. Okay, so make a note. If you're not sure about those answers, make a note of it and make sure you bring it along to the lesson to ask about. Again, some more questions to try. Let's pause the video and give them a try. I'm going to reveal the answers now. Again, pause the video, check your answers, and any queries that you've got, take along to the lesson. Last thing is tree diagrams. So you've seen tree diagrams before. They're an effective way of showing outcomes of two events which happen in succession. You can, I would agree with Dr. Frost here when he says that, that their use is easily avoidable, because you can pretty much use Venn diagrams for every situation, but you need to be able to use them. So have a read of this example here and the Venn diagram that matches it. No, it doesn't. That's nothing to do with that one. So part A, if we're using a Venn diagram, then you've drawn your Venn diagram and the probability of getting yellow, yellow is given here. Probability of getting green, green is here. It's important, but don't get too hung up on this. It used to be something that was really stressed on, and it's a bit of a shame it's taken out of the spec. But here you are multiplying probabilities, but they are not independent probabilities. It's a different rule that's being applied to do with conditional probabilities, the ones I spoke about earlier with the given that thing. And you are allowed to do it, but don't think it's because you have independent probabilities, because it isn't. And I think this is one of the reasons why people think they can just multiply probabilities to get the AND rule. And we've got the answer there for A. So as Dr. Foster said, he likes to list out the matching sequences of outcomes first, then find the probability for each. So he hasn't actually used a tree diagram at all. Same goes for part B. So if you have a look at that and then query it with your teacher if you're not sure. And the last question, if you haven't tried it, then please pause now. And the answer is this. So you think about it. If you get, this time we are looking at independent events. Well, we're assuming that actually. It doesn't say in the question that they're independent. So you're having to assume that they're independent, which is something that is a bit dodgy, because you'd like to think that as someone keeps shooting at a target, they'd improve. But there we go. So here are the questions that you were asked to do. You were given at the start of the video, and what I'd like you to do, please, is to do these questions and bring your answers along to your next lesson, the probability lesson that you would have had. If you're just watching this video because you like to watch videos on probability, then you need to ask your teacher to give you the answers. Okay, that's it. That's just over 20 minutes. There's a lot of information, so you might need to watch the video a couple of times, and we will consolidate in the lesson what you have learned.